All right, ladies and gentlemen, so we're going to talk about the line of best fit. This may or may not be in your shrunken notes packet, but it is part of the statistics unit, so I'm going to go over it anyway, and I'll post it for you, and then I'll do 9-7 is the next one you'll get from me. So let's start with this. So line of best fit, we're going to look at the correlation between the data that's here and the date, and can we find, is there a relationship either positive or negative? So the first thing we're going to look at is the correlation coefficient, which is the R in this situation, and it's going to measure the strength of the association between the data points there. So we're measuring the strength of our association here. And it's either going to be a negative correlation or a positive correlation. So when we're looking at that, we're going to take our ruler or any straight edge. You know how I feel about that. That's normally where we do an ID check. And we're going to go right in here. And I'm going to put a line through the center of where I think it's going to hit the majority of the data. I'm going to imagine my line is straight. So through the middle there, that's going to go through the majority of the data points. So when I'm looking at that, that's going to give me an approximation of what my line of best fit is going to be. So then we want to make sure that we know that the closer that our absolute value of R is to 1, that it's going to be a stronger positive association. So if we're talking about a value that's going to be 90.99, then that is going to be a very strong positive correlation for us, and that's talking about a positive 0.99. Or on the other hand, if we are talking about a negative 0.99, that's going to be a very strong correlation as well. It's just going to be a negative correlation. Whereas if it's not something at 0.99, so close to 1, if we're talking about something that's a little bit further away, so say we're looking at 0.3 here, that's going to be a weak positive correlation, but still a correlation in and of itself. So we're going to make sure that we keep an eye on that. So this doesn't mean that there's not a correlation, just means that there's less of one. And correlation just means like a relationship between the two. All right, so if we're looking at line of best fit, you can do a linear, it's going to be a linear model, and this is something that you can do on your calculator. So we'll go into that part, but the first thing I want to point out here is that this is just a reminder that that's going to be our y-intercept. Here. And that this A out front, normally we're used to seeing a B out, an M out there, but in this case they just changed the letter. It's just an A. It means the same thing. That's your slope. So our A is the slope. So those are going to be our values there. So now as we're going to move up, we're going to look at this chart here, and we're going to use our calculator to set up this correlation so that we can see the line of best fit. So we're going to see how they got this equation. So what we're going to do there is we are going to take these are going to be the x values, and these will be the y values. And now we're going to use our calculator, and we're going to give ourselves some options here. So the first thing we're going to do in our calculator is we're going to go to stat, and I'm going to write out the instructions, and then we're going to do them. So stat is the first button I'm going to press, and then I'm going to have to go in 2 directions from stat. The first one I'm going to go through is I'm going to do stat edit. And if you remember from our statistics, the beginning part of our statistics stuff, that's how we enter in data into L1 and L2. So I'm going to stat edit, and then I'm going to enter my data. And I'm going to enter the L1 and the L2 categories this time. L1 is going to be my X, and L2 is going to be my Y, and that's from this table up here. So my L1 and my L2 are from my table here. So all my X values are going to go into L1 and all my Y values are going to go into L2. Then the next thing I'm going to do is I'm going to go back to stat again, and I'm going to press calc, go under calc this time. And then I'm going to pick line of regression. I'm going to pick the linear option. So I'm going to get the one that says AX plus B. Okay. That's because I want this to be in that form. What's going to come out is my linear regression equation, which is this here. It's going to tell me what my A is. And then it's going to tell me what my B is. So we're going to pull those up on the calculator right quick. So my fancy calculator is dead. So let's hope we can see this one. So when I turn it on, okay, cool. We can see it. So clear, clear, clear. I'm going to see if I can zoom in for you guys a little bit more. Okay. And so I'm just going to follow the keystrokes that I have right here. And then I'm going to show up on my calculator. So it's on. And then I'm going to have stat. And I'm going to edit. And as you can see, I put in my data. I have 19, 31, 34, 35, 39, 39, and 43. Then I'm going to have on this side, I have my Y values, which are the 410, 580, 590, 570, 640, 680, and 660. So all my stuff is in there now. I already put those in. You know how to put the data points in, not very difficult. Now I'm going to go back to stat, and this time I'm going to go over to calc. And if I look down at 4 here, it says to me that that's going to give me my linear regression in linear form. So that's what I want. Bam. My X values list is L1. My Y values list is L2. I don't care about the frequency list. Store my regression. That we don't care about that one. We just want to go down to where it says calculate and hit enter. Now I have my A is 11.0555. So I'm going to make it 11.06. So here we have our 11.06. That's where they got that from. And so then if I'm looking at my B, it says 210.9538. So we're going to round that to 210.95. Now I see where they got their values. It all came from the calculator. Okay. All right. So I'm going to zoom back out just a little so we can see more. Okay. So now we have, zoom out one more time. Boop. Okay, so now we have our values. Now we can go ahead and calculate. Right here it says, what would the estimated calories be for 50 grams of fat? Well, I'm going to plug in for my X. So I'm going to have F of 50 is going to equal to 11.06 times, well, in this case, my X is going to be 50. And then I'm going to add the 210.95. Save yourself some time, dude. Plug it into your calculator. So, plugging it straight into my calculator. 11.06 times my 50 plus 210.95. When I hit enter, and I'll zoom for you so you can see my calculator. So when I hit enter, now I have 763.95. So my F of 50 is equal to 763.95. Done. There's my answer. You can test out what you know for the quick check here and the quick check here. And that's just the check for understanding. So in this case, what would the estimate of fat in grams be for 1,000 calories? So this time my X is 1,000. That's going to be one of your quick checks. While what does the slope of the line represent in the context of the problem? That's just getting you to understand what does our slope represent in this situation. It says fit a line. Yeah. Fit a line of best fit, so a regression line for the following data. Fat per calories. So then my slope represents something along the lines of fat per calories. Okay, so I'm going to go ahead and end this video here, and then we'll work on the second page of this in the next video just to keep it short. Finish out your quick checks. Good job.